Today's topic is going to be the conservation of mass. The conservation of mass. And this is going to be TEK 8.5E. Okay, so I know we briefly covered the conservation of mass last week, but of course, I don't feel comfortable moving on until I am sure and positive that all my kiddos understand. So we're going to briefly discuss it today. And yeah, because I just want to make sure all my kiddos understand. So first, we have to make sure we all understand what is the conservation of mass. So let's write that out. Conservation of mass. And let me draw a little line because we're going to get ready to write out the description. So what is the conservation of mass, you guys? It is a law. So that masses cannot be created. They cannot be created or destroyed during chemical reactions. And so we just saw the different evidence types that lets us know a chemical reaction is occurring. So now we get ready to lean more into the conservation of mass. So it says masses cannot be created or destroyed during chemical reactions. It can only be conserved. So you know when you hear the word conserve, that means to save, right? So basically it's just being saved. Mass is conserved from the reactants, which we're getting ready to talk about, the reactants, which is before the chemical reaction, to the products. And underline and highlight that word conserve. That word is very important. Conserved. Mass is conserved, meaning it is saved. I'm going to put that in parentheses. I didn't put it before, but I'm going to put it now. You know, anything to make it easier for us to understand. Basically, you guys, it's just a fancy way of saying is it equal? Is it equal on both sides? Is it equal on both sides? Or you can ask yourself, is it balanced or unbalanced, right? And I promise it's going to be easy. Is it balanced? Or is it unbalanced? All right. So think about whenever we're doing a lab in class or we're doing virtual labs, right? Sometimes we're going to be adding atoms or combining atoms. And when we do that, we will always have reactants which will produce our products. Reactants will be on the left side. Reactants will be on your left side, and products will be on your right. Okay, make sure you copy this down. So, let's say, for example, right? So let's start our lab. Let's say I am giving you example number 1. Let's say I am giving you CH4 plus 2O2, right? And it's going to produce CO2. And we know CO2 is carbon dioxide plus 2 molecules of H2O, fancy word for water. You know that this is the left side, so this is going to be considered our reactants. This is our right side, this is going to be considered our products, right? And actually, let's highlight this real quick. This is the left side is always going to be your reactants, you guys. And right side will always be your products. The little arrow in the center, that just means it's going to be produced. So I'm taking two things and I'm combining them to form something new, right? Chemical reaction. So this is produced. Parentheses. So first, just like we've been practicing before, we've been counting atoms, we want to know, is it equal on both sides? We want to know, is it balanced on both sides, balanced or unbalanced? Basically, we want to know if we're conserving our mass, if we're following the conservation of mass law. So let's break it down. The first atoms we see. I know I see carbon, I see C. Let me grab my periodic table. I know that C is for carbon, so I'm going to write that out. I see an H. We all should know, but we all know that H is hydrogen, right? Grab your periodic table. H is hydrogen. And then I also see oxygen. Oh, grab my periodic table. Let me scan and look for it. Oxygen right here, group 16. 6 valence electrons, right? So let's count it out. How many, starting with carbon, how many atoms of carbon do we see? So I see C. There aren't any other carbons. I don't see a subscript. I don't see a coefficient. I don't see a parentheses. So I know that that is an invisible one. My next element, I know I see a H. H stands for hydrogen. We see this little bitty 4 right here. We know that's a subscript. So we have 4 atoms of hydrogen. Now look at oxygen real quick. We see a subscript of 2, but we also see a coefficient of 2. So we know that we have to multiply those two numbers. 2 times 2 will give us 4. Let's add them all up. 1 plus 4 is 5. 5 plus 4 is 9 atoms. And let's put a little box around that. Now, same thing we do on one side, we're going to have to do to the other side. So same thing. Let's break it down. Which elements do we see within this chemical reaction? So I see carbon. I see oxygen. I see 2, but we only have to write it once because we're counting the total of them. I also see hydrogen. So now let's tally them up real quick. How many carbon atoms do you see? So I see 1 right here in the beginning. I don't see any coefficients next to it. I don't see any subscripts. It's not in parentheses. So for now, it's just 1 atom of carbon. Oxygen. Oh, I see it twice. So I see 2 right here. So I'm just going to pause on that. I'm going to write the first 2. We're going to come back to it. Let's go to the next element. We see hydrogen. We see a 2, a subscript of 2. We see the big old 2 in the front. You know that's the coefficient. You know that we're going to have to multiply those two. So that's going to be a total of 4. And now let's go back to our last oxygen atom, right? Right here, I see a O. It's no subscript, but we see that it's also attached to this big 2 in front. So that means it's going to be 2 times that invisible 1 of 2. So I'm going to add that on to my oxygen, which equals 4. So add those together. 1 plus 4 is 5. 5 plus 4 is 9. There are 9 atoms on the product side. 9 atoms total. So now, let me grab my pen because I want this part to stand out. We're going to ask ourselves, you're going to ask yourself, does it show conservation of mass? So let me write that out to the side. Does it show conservation of mass? Question mark. Write this out in a different color if you can, you guys. Put a bubble around it. This is what you're going to always ask yourself. Does it show conservation of mass? Does it follow the conservation of mass law? Is it equal on both sides? I know I see one atom of carbon on the reactant side. I see 1 carbon of atom on the product side. I see 4 atoms of hydrogen on the reactant side. I also see 4 atoms of hydrogen on the product side. I see 4 atoms of oxygen on the reactant side. I also, you guys, also see 4 oxygen atoms on the product side. So is it equal on both sides? Yes. We have 9 over here. We have 9 on the products. Is it balanced or unbalanced? It's definitely balanced because the numbers are equal. So does it show conservation of mass? And the answer is yes. Exclamation point. Yes, it does. This equation, we're writing all of this out. We're practicing together. This equation shows conservation of mass because the reactants, which is on our left, right? The reactants, they equal our products. So yes, mass is definitely being saved. So yes, it does show conservation of mass because reactants is equal to our products. The mass is definitely being conserved. It's definitely being saved. So let's do one more example. Example number 2. So we have 2 molecules of H2O2. It is producing, because that's what the little arrow means, correct? It is producing O2 plus 2H2O2. So let's break it down. We have our reactants on the left side. Just want to make sure we all remember these are things that we cannot forget. We have our reactants on the left side. Those are what happens before, what we have before. And we have our products that are on the right side. So same thing, we're going to break it down. So take your periodic table out. What are the first elements that you see? So I know I see hydrogen. I know I see hydrogen. Why? Because I see a H. Take your periodic table. You know that H stands for hydrogen. Hydrogen. And I also see O, find a periodic table. We know that O represents oxygen. And now let's calculate how many we have total, right? So starting with hydrogen, I see H, I see a subscript of 2. But we have this big 2 in the front. We have this coefficient. You know when you have the coefficient in the subscript that we have to multiply. So that will be 2 times 2, which is going to equal 4. Oxygen as well. I have a subscript of 2. It's included, it's in the same molecule, so it applies to that. It also applies to the coefficient of 2. So 2 times this 2 will give us 4. Let's add them up. That is a total of 8 atoms. Let's do our product side real quick. So I'm starting off with, I'm going to go ahead and put hydrogen because I want to try to keep it balanced. You know, same word, same lines. So I'm going to put hydrogen because I know I see hydrogen, right? But I also know I see oxygen again. We see oxygen twice, however, but we're only going to write it one time. So starting with hydrogen, I see a 2. Subscript of 2 is followed behind that coefficient of 2. 2 times 2 is 4. Oxygen, we have oxygen in the beginning, so that's going to be 2. No coefficient, just a subscript. And we also see oxygen at the end, so I'm going to put a little plus sign, right? So that's 2, a subscript of 2. Followed behind the coefficient of 2. 2 times 2 is 4. So that's a total of 6 atoms of oxygen. Let's add them all up. 6 plus 4 equals 10 atoms total. And let's put a box around it. So now we ask ourselves that fancy question again. Does it show conservation of mass? Ask yourself, is it equal on both sides? I know I see 8 on the reactant side. I see 10 on the product side. Is it balanced or unbalanced? I see 8 atoms on the reactant side. I see 10 atoms on the product side. Is it balanced? No, it definitely isn't this time. So no, it's not. Why not? This equation does not show conservation of mass. Show conservation. Kind of squeeze that in real quick. Of mass. It doesn't because they're not equal. Reactants. Does not equal. Equal sign with a cross through it. It does not equal our products. That is why it doesn't. You know, with the conservation of mass, they have to be equal on both sides. Basically, another way you can ask yourself, is it balanced or unbalanced? The first example, they both were balanced, so this does show conservation of mass because mass was not destroyed, was not created or destroyed. And they were both equal. But however, in the second example, they were completely different. So this one does not show conservation of mass. Perfect, you guys. Do me a favor, make sure you copy all of these notes word from word. You can add some doodles if you want to. When you're finished, go ahead and take a picture and submit it for a grade. Talk to you soon.